Before we dive into the announcement, it's important to understand what particle accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets and the world's largest and most powerful particle accelerator. It represents the pinnacle of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions of the universe's birth. But could this machine, designed to unlock the secrets of the universe, hold the key to something far more ominous? CERN, founded in 1954, is one of the world's most prestigious research organizations with 23 member states and thousands of scientists. It serves as a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one part of a vast network of accelerators and experiments. Imagine a racetrack not for cars or horses, but for subatomic particles in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. These collisions create temperatures 1,000,000 times hotter than the core of the sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together, they act as colossal cameras capturing snapshots of these collisions. Scientists then sift through the debris, looking for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the macrocosm. But with every answer comes a new question, and with every discovery, a new challenge. The LHC is not just a scientific instrument. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unlock forces we cannot control? In the hallowed halls of CERN, where the boundaries of human understanding are constantly pushed, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a voice of authority in the world of particle physics, has recently made an announcement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. The physicist also went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not just a theoretical concept. It's a tangible reality within the LHC. The temperatures, the pressures, the raw energy, all mimic the conditions of the universe's infancy. It's like standing at the dawn of time, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go terribly wrong. Back in 1978, the Russian physicist Anat Borsky experienced a disaster that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was otherworldly. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone. Yet, he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, astonishingly, Borsky's intellectual capabilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC are not to be taken lightly. The potential for unforeseen reactions, the very fabric of space and time being manipulated, these are not the stuff of science fiction, but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, enigmatic entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, swallowing the Earth from within? Though scientists at CERN have assured that any black hole created would be unstable and evaporate almost instantly, the mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy weight is dropped onto it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a stylistic metaphor for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both bizarre and beautiful, there exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This enigmatic dance of particles has even caught the attention of some world-famous scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but the entire universe itself. The esteemed British cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN. In his book On the Future Prospects for Humanity, he explored the potential risks associated with particle accelerator experiments, including those at CERN. His words were not merely cautionary. They were tinged with a sense of existential dread. He spoke of a worst-case scenario where an ill-fated experiment could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of spacetime, resulting in a cosmic catastrophe that could engulf the entire universe. Rees's concerns were not limited to theoretical musings. He assigned a probability to these catastrophic outcomes, albeit a low one. But even a minuscule change, he argued, should give us pause. The stakes are unimaginably high, and the margin for error is razor-thin. The scientists at CERN have calculated the probabilities, run the simulations, and examined the theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible exploration, recognizing that there are widespread fears and concerns surrounding the activities of the LHC. He emphasized that there are rigorous safety measures in place, extensive reviews and protocols that ensure the LHC's operations are conducted with the utmost care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and so unstable that it would evaporate in a flash of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a fleeting moment of cosmic awe, a glimpse into the abyss, and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This notion, though largely dismissed by the scientific community, has captured the imagination of many and has become a subject of fascination, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities that we do not understand? The idea of opening a portal to hell has even been sensationalized in various media, adding fuel to the fire of uncertainty. But how did this idea come to be, and what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading candidate for a unified theory of everything, posits that there may be more than the familiar 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from our perception, but they could theoretically be accessed or revealed under extreme conditions. Now imagine the LHC as a cosmic key unlocking doors that have been sealed since the dawn of time. When protons collide at energies never before achieved on Earth, they could, in theory, create ripples in the fabric of spacetime, potentially exposing hidden dimensions. While the scientific community is largely skeptical of such sensational claims, the very idea of particle accelerators unlocking the secrets of the universe has led to wider public interest in the potential risks and consequences of such experiments. In the end, the LHC stands as a powerful symbol of human curiosity and ambition. It is a testament to the progress we have made in understanding the universe, but also a reminder of the dangers that come with such knowledge. The universe may be vast, but the more we uncover about it, the more we realize how little we truly understand. The quest for knowledge is one of humanity's greatest achievements, but it is also fraught with uncertainty and peril. Only time will tell if we are ready for what we might uncover next. The Large Hadron Collider, LHC, is a marvel of modern science and technology, but it also opens the door to questions that challenge the very foundation of what we understand about the universe. The machine itself is an engineering masterpiece, stretching across a vast underground ring and featuring the most advanced and precise equipment ever built. It brings together a global network of scientists and researchers who are united by one goal: to answer some of the most profound questions about the cosmos. However, as scientists push the boundaries of human knowledge, they also face significant challenges, both theoretical and ethical. One of the key areas of study at the LHC is the quest for understanding the forces that govern the universe. For centuries, scientists have sought to unlock the mysteries of gravity, electromagnetism, and the strong and weak nuclear forces. The LHC provides an unprecedented opportunity to study these forces in extreme environments. The collision of particles at such high energies mimics conditions that existed just moments after the Big Bang, when the universe was a hot, dense soup of particles. This allows researchers to probe the behavior of matter and energy in ways that were once thought to be impossible. Yet, with the potential to make groundbreaking discoveries, the LHC also raises important questions about the limits of scientific experimentation. The possibility of discovering new particles, such as supersymmetric particles or dark matter, could revolutionize our understanding of the universe. But these discoveries could also have unintended consequences. There is a growing awareness among some physicists that the experiments being conducted at the LHC may be unlocking more than just the secrets of the universe. They may be revealing new dangers or forces that humanity is not yet equipped to handle. One of the most intriguing and unsettling ideas in this regard is the concept of a vacuum decay. This theory suggests that under certain conditions, the energy generated by particle collisions at the LHC could cause a catastrophic shift in the fabric of spacetime, triggering a chain reaction that could alter the very nature of reality itself. While the likelihood of this occurring is extremely low, the potential consequences are so severe that some have argued it is a risk that should be carefully considered. A vacuum decay event, if it were to happen, could cause the collapse of the universe as we know it, potentially leading to the destruction of all matter and energy within our cosmos. Despite the speculative nature of these concerns, the LHC continues to be a focal point for scientific inquiry. The excitement surrounding the possibility of new discoveries often outweighs the cautionary voices. Every day, thousands of scientists work tirelessly at CERN, driven by a deep desire to uncover the fundamental truths that govern existence. Yet, as the LHC operates at the cutting edge of science, the ethical implications of such powerful experiments remain a topic of ongoing debate. Another area of concern is the potential for creating phenomena that we simply do not understand. The LHC has already demonstrated the ability to create exotic particles, such as the Higgs boson, that were previously only theorized. However, This ability to create new forms of matter also raises the question of whether we could create particles or entities that could pose unforeseen risks.